Hello students, so we will continue our video for physics, okay, class 8. So today we will discuss about explanation of liquid pressure on kinetic model, okay, explanation of liquid pressure on kinetic model, okay. So the molecules of a liquid in a vessel, okay, suppose if we put some liquid on a vessel, they are not stationary, that means they are not settled down or at rest, they are continuously in motion, but the molecules, what they do, they randomly move in all possible direction, okay. So that means if you put some amount of liquid in a vessel, then the molecules are not stationary, that is not at rest, rather they continuously move in all possible direction, and in doing so, that means when they are in motion, the molecules of a liquid strike against the sides of the container of the vessel. That means suppose this is a vessel where we have put the liquid in this container, the molecules continuously strike on the wall of this vessel, and hence what they do, as they are continuously striking the vessel, so they exert some specific force, because they are exerting on the wall of the vessel, that's why they are applying some force, and this force exerted per unit area on the side of the vessel is the cause of liquid pressure. That's why there is a pressure on the wall of the vessel, and this pressure is the liquid pressure, okay, fine. Next, again we will have the liquid pressure on kinetic model. So we have the gas pressure on kinetic model, okay. So if we see the gas pressure on kinetic model, so what we have, the molecules of gas contained in a closed vessel are not stationary. Again, if you take any closed vessel, suppose we can see this figure, okay, suppose we take a closed vessel, this is closed, and inside it there are some gases, okay, there are gases, okay. So we know that the gases in a vessel do not settle down, they continuously move, okay, they are not stationary, they continuously move in all possible direction. Here the particle will move in this direction, it may move in all possible direction, and in doing so, the molecules again of the gas again strike the sides or the wall of the vessel, and hence as they are continuously striking, so there will be some force exerted by that particle or molecules, and this force exerted per unit area on the side of the containing vessel is cause of the gas pressure, okay. That's why there is some gas pressure, okay. Similarly, effect of reducing the volume of gas on pressure, okay. So next we have the effect of reducing the volume of gas on pressure in a closed vessel. So you can see the two figures A and B. Initially the figure was the volume was 20 centimeter cube, and we have applied a downward force, this force F, and the volume of the air is 10 centimeter cube. That means we have reduced the volume of the gas, okay, on a closed vessel. Now if you see the meter, this meter, okay, the reading was like this. Now suddenly the reading has been increased, that means the pressure has increased. So if we apply a pressure on a closed vessel, then the volume of the gas reduces, okay, and if we release the pressure, obviously the volume of the gas can be increased, okay. So if we release the pressure, or if we move this piston upward, okay, now the volume will be your 40 centimeter cube, we can double it, okay, or we can compress it, fine, okay. Now explanation of heat conduction on kinetic model of matter, okay, how heat conduction is explained, heat. Now the mode of transmission of heat energy from one atom to another atom in the direction of the lower temperature without the actual movement of atom from their mean position is called conduction. So what is conduction? It is the transmission, a transfer of heat energy from one atom to another atom in the direction of lower temperature, okay. The heat will move from hotter to lower temperature without the actual movement of atom. Generally atom does not move, but the heat from one atom move from one atom to another atom and from higher temperature to lower temperature, and that movement of heat without the movement of atom is known as conduction. And the phenomenon of conduction can be explained on the basis of kinetic model of matter. Okay, so we can explain the phenomenon of conduction with the kinetic model of matter. Okay, how? So let us see. So when a solid is heated from one end in fire, its atom gets heated. Okay, suppose let us take one example. Suppose this is an iron rod. Okay, and suppose we have put some air, we can say heat, we have burned it. Okay, so now this end will get heated and the heat will transfer from higher heat to the higher temperature to the lower temperature, because at this end, after some time, this end also, at end B also, we will feel some hotness. Okay, so that means when a solid is heated from one end in fire, its atom gain heat energy. Here the atom will gain energy. At point B, the atoms will gain energy, and the gain of heat energy by the atom increases their kinetic energy, and with the increase in temperature, kinetic energy also increases, and hence they vibrate about their mean position with more amplitude, and thus what we can say that the energetic atom strike against the neighboring atom. That means there are some atom neighboring to this atom, so heated atom will strike to the neighboring atom and transfer a part of kinetic energy to them. Some amount of kinetic energy is transferred from one atom to another atom. So in this way, more and more atom along the length of the conductor gain kinetic energy. That means more atom here also, some atoms are there, so they will also gain some kinetic energy. Hence, with increase in kinetic energy, we know the temperature also increases. So as the kinetic energy increases, so their temperature also increases. That's why, so if we heat the solid at one end, then that heat will transferred from one end to another end. Thus, heat energy, we can say that the heat energy is transmitted by conduction. You can say that atoms have not moved from one end to the other end. Only the heat have moved from one end to another end. So this process is called our conduction. Fine. Similarly, explanation of heat convection. Now here the word is convection, not convection, conduction. Okay. So explanation of heat convection on kinetic model of matter. So before going to that, you need to learn that what is convection. Okay, conduction we know, we have learned what is conduction. Okay, now we will learn about the convection. So convection is the phenomena due to which particles of medium actually move, particles of a medium actually move towards the source of heat energy. So in previous one, conduction, the particles do not move from heated from higher temperature to lower temperature, rather the heat transferred from higher temperature to lower temperature. But here the particles of the medium actually move. Okay, here particles move towards the source of heat energy, and then on absorbing heat energy move away from it, and thereby making a space for other particles of medium to move towards the source of heat, and is called convection. That means we can see some example that we have burned, suppose we have we are burning something. Okay, there are some particles here also. So this particle will get heated and they will start moving from this place to another place. So the particles here, okay, will again move to the heated one or near the fire. So that means in this way the particles heated and changes its place, and again the other non-heated particle will come closer to the heater, we can say the fire, and they will get heated. So here the particles are actually moving towards the source of energy, heat energy, and they absorb heat energy and again move away, and again make some space for other particles to come that place, and the other particles again move towards the heated particle source of the heat, and again they get heated and again they move from there, and some empty space is created, and again the non-heated particles come to the heat, to the source of heat. So in this way this process is known as our convection. Okay, and the phenomenon of convection can be also be explained on the basis of kinetic model of matter. We will discuss this now. Okay. So when a liquid contained in a vessel is heated from the base of the vessel, then the particles of the liquid in the region of the heat source absorb heat energy, and the heat energy absorbed by the particle increases the kinetic energy, and hence they move vigorously, and these energetic particles move away from the source of heat, that is rise upward, and this results in the fall in pressure, and to equalize the pressure, the particles of the liquid from the colder region sinks down and they move towards the source of heat, and this in turn give rise to convection currents. That means suppose there is one container, and in this container some liquids are there. Okay, suppose we take one water, and suppose one burner is here. So if when we burn it, the temperature near this burner, or we can say the particles, water molecules near this burner will get heated up, and what they will do, they will move away from this source of heat, or they will move upward, and the particles which are on the upward, that are we can say the colder particles, they will again come down to the heated one, okay, near the source of heat, and in this way the the colder particle will gain energy and move upward, okay, and then there will be create a low pressure, and again, so to minimize it or to equalize it, the particles which are situated in the colder region will again come to the source of heat, and again they will heat it, and again they will move away. So in this way the complete or all the particles of the water will get heated, okay, or they will increase the energy. So we have explained the heat convection and heat conduction on kinetic model of matter. Okay, so up to this we have our first unit, or not the first unit, this is our first chapter. So so try to solve the exercise 1.1. okay, so try to solve the exercise 1.1, which is in page number 14. So you can fill up that, and after solving them you can send me, then I can check whether it is correct or not. Okay, so question number A is fill in the blanks, you can easily do it. Question number B is also true and false. So or else what we will do in the next video, I will send the solution, or I will discuss it then you can send me, or you can send me, I can check also. Okay, so in the next video we will discuss about that exercise 1.1, and after that we will continue towards the next unit. Okay, change of state in matter using kinetic theory. So if you find any difficulty in chapter 1, then you can contact me. Okay, I will come in Monday and Tuesday in school, so you can contact me. Okay, thank you.